The first reaction that we're going to look at in the reactions of alcohols is the combustion of alcohols. You can see the general equation for the combustion of alcohols on the board. In exactly the same way as with the alkanes and the alkenes, when an alcohol is completely combusted, it forms carbon dioxide and water. Now, alcohols almost always undergo complete combustion rather than incomplete. So you're not going to see incomplete combustion happening with alcohols. The reason for that is the alcohol contains oxygen anyway. It's got an oxygen atom in it anyway, which means there's more oxygen available, which means that incomplete combustion is very unlikely to occur. The example that I've given you in the symbol equation is of methanol reacting with oxygen. So that's the alcohol which has only one carbon and it's reacting with the oxygen to form carbon dioxide and water. And as you can see, this equation is currently not balanced. So the first thing we're going to do is we're going to balance this equation. Okay. So, first thing that we're doing, we're looking at the number of carbons on both sides of the equation. Okay, the number of carbons is 1 on the left and 1 on the right, so we don't need to do anything to that. The second thing we're going to do is we're going to look at the number of hydrogens. Okay, we've got 4 hydrogens on the left and only 2 on the right. So I'm going to add a 2 in front of my water there. Okay, the oxygens is the tricky part because what people always forget is that there is an oxygen inside the alcohol as well as the oxygen you're reacting it with. So we need to add together the number of oxygens on the right-hand side, 2 oxygens and another 2 oxygens. So total number of oxygens there is 4. We need to make it so that there are also 4 on the left-hand side. One of them is already there. So actually from this oxygen, we want there to be 3. Okay, it's O2, and therefore that number will be 1.5, or 3/2. Remember that if you don't like using halves in equations, you can get rid of the halves by multiplying everything by 2. So you could have 2CH3OH plus 3O2 gives you 2 CO2s and 4 H2Os. We're going to compare the combustion of the alcohols with the alkanes now. So in the Bunsen burner gas taps, I have got methane. It's taking a little while because the gas taps haven't been on in quite a while. There we go. Okay, so we've got methane being combusted to form carbon dioxide and water there. And in my spirit burner, as you can see from the label, I have got ethanol. Okay, so as we can see, both the alkanes and the alcohols burn extremely well. We've got the alkane on the right and the alcohol on the left. Okay, into my Bunsen burner flame, I'm just going to put an empty test tube. Get this out of the way a little bit. And as you have seen several times when you've been doing experiments using the Bunsen burner, okay, quite quickly a layer of soot will appear on the outside of my test tube. Remember that soot is actually just carbon. So when you start to form that black powder around the outside of the test tube, what's happening is that you are undergoing incomplete combustion. So there is not sufficient oxygen for the alkane to combust completely, and therefore you're going to find that a layer of soot, carbon, appears on the outside of the test tube. Okay, and that's already started here. I don't think we're going to be able to see it very clearly. So I'm just going to wipe the test tube with a piece of cloth and hope that that allows it to appear. Okay, so you can see on my paper towel that a small amount of soot has appeared, leaving a dirty mark on the paper. If I do the same thing using the ethanol burner, from what we've already seen, where I gave you some information about the combustion of the alcohols, we know that combustion of alcohols is almost always complete combustion. It's nearly always complete because there is enough oxygen present. There's extra oxygen inside the alcohol, and therefore complete combustion will usually take place. I'm just going to leave this in a minute more to try and make it as fair a test as possible, because I left the test tube in the Bunsen burner a long time. But what we should see is that no carbon is produced in the case of the alcohol, because complete combustion is happening. So our products here are carbon dioxide and water, not soot or carbon. Okay, so if I do exactly the same thing using a different part of the paper, this time no soot. Ethanol obviously isn't the only alcohol. We've also got methanol and propanol. And as we can expect, these are going to behave in very similar ways to ethanol. However, we should see there that a key difference between them is the amount of energy they give out when they are burning. If you look at the flame for methanol, it's a fairly small flame, not that much heat energy is being released. Ethanol, with 2 carbons, is slightly more so, it's a bigger flame, and propanol, the one with 3 carbons, has got a much, much stronger flame. So what we're seeing, as the length of the alcohol, or the number of carbons in the alcohol, increases, we find that they give out much more energy when they combust. So the flames for the longer chain alcohols are going to be much bigger, stronger, more forceful. They will give out more energy.